Welcome to a very short stream. I'll be going in a short while. Yeah, I decided to do some quick work. For one, I expanded this. And I also added some stuff here. Object data buffer sizes can't handle much more than 16 times 16 objects. Yeah, so I wanted to do some more debug rendering, see if I can get that done for our grid. So the way that we do a debug primitive here is this call. Let's see, let's create a void draw debug ray. Let's see, debug mesh data is probably a type, then a color. Where do we define this? Let's see, struct debug ray data, and let's do a color as well. Oops, I also forgot to set the chat here, I think, in OBS, didn't I? I think so. There we go. So let's do a DirectX XM float free start point. And let's do endpoints. And this should basically be it, right? In order to do debug primitives, spheres, blah, blah, blah. Yeah, right now let's structure it like this. So we aren't gonna scale or anything of the like. We're basically just gonna draw some lines. In terms of our front end here, let's do debug line. Didn't I? Debug ray. Now that's it. This is actually, well, yeah, we don't need a transient data store for this. We can register the call directly. debug raise. And let's create a method. And let's just add debug ray data. Ray data. And let's do draw call data store. Debug ray. Implement spec. The ray data here. Okay. And then inside our draw call, let's see, void debug ray render pass debug ray data race. And we will do our stuff. And then oh, let's see, whenever we do update debug data. Yeah. Maybe we want a separate, don't we already have a separate vertex buffer for this? I mean, like debug render pass here. Of course, let's do DX render debug ray render pass. Let's do draw call data store debug rays here. Let's see. Debug primitives. Let's see. Create debug buffers. This is the upload heap. Yeah, so the vertex buffer and index buffer is no. No? Oh, we actually create a line vertex buffer for this. Yeah. So let's do that. Yeah, so we have these 3 buffers here for the primitives, and then we have these 2 buffers here for the lines themselves. Uh, let's see, per instance. Inputs. Yeah, input data is per instance data. Yeah, I think I'll change it to instance data then. Okay, so we actually have these buffers here, debug. Do we actually create a view for it? I'm not sure. Oh, we do. Okay, so let's set up our pipeline stuff. Debug primitive. Um, let's do debug line pipeline. Let's see, and DX12 backend pipeline type debug. Uh, lines arrays. Yeah, so let's create that pipeline. I guess we should create a shader set that is called debug and move the debug primitives into that section. Let's do debug slash debug prim. Yeah, that's. Let's do primitives. And let's do primitives here. Let's see if we are still good. Yeah, we're good. Delete this one. Okay. Okay. Uh, debug ray PSO, and we don't need this. Let's see position, and then maybe we want an alpha as well. Yeah, let's just do that, even though. Oh, we can specify classification, right? After the input details. Let's do D3D per instance data. Let's see. Okay. Okay. Let's see. Vertex buffer view. Good view. And we cast it. And this is of course the line buffer. And there we go. So we fixed that part here. Okay, so we have our pipeline stuff here. Maybe. Okay, so this call here should probably be modified a bit. So the one down here, no, yeah, maybe this one actually should be done as well. Update frame resources. Let's see. Debug render pass here. Yeah, maybe this is just const unsigned int count. And this is going to be const. Let's see, prim colors, prim matrices, and then our arrays. And let's move this. Prim colors and matrices. Okay, let's do that and then do const unsigned int size, our count here. And then inside here, we will copy this and just grab our size. And we don't actually call the, what? Don't we? Oh, it's here. Well, it shouldn't be here. This should be moved up here due to efficiency. Always you want to upload uh, your data first. Upload, debug, data. Debug, draw calls. Okay. Update debug frame resources, and then let's grab our debug stuff here. for unsigned in I equals 0 less than raise dot size I plus plus. Okay. Just a sec. Gonna grab a phone charger. All right, almost there. So we want to actually, maybe we just want to copy our data. I mean, this is going to be 3 floats. 3 times 3 floats. But it would be aligned a wrong way. So I guess we could just change this and just live with the natural padding here. Just for efficiency. Yeah, we will use a few more CPU cycles on this, but huh? 1, 2. Oh, it recognized it now. Goddamn intelligence. Always messing with me. Okay. So what we actually would be able to do is something like this instead. Oh. Do we actually want indices? I'm not sure. Do we need indices? Well, whenever I do the draw call, instance count. Let's just do maybe draw instanced. Vertex per instance. Yeah, that's it, what we're looking for. We don't want an index buffer because we're always going to draw 2. It was only if we were drawing something very advanced with the lines, but right now we have 2 separate pipelines. We have one that renders primitives, and we have one that renders arrays. So, yeah, we will just use that call. Okay, let's see. Then we won't create this one. And let's do, this is the index buffer as well. Okay, let's try just creating the, what do you call it? Vertex buffer here then. Let's do memcopy. Buffer, get memory here. And let's do raise dot data. And let's do it Raise dot size times size of debug ray data. Okay. Okay, and let's see. Primitives, raise. Vertex shader. Let's see, raise. Okay. Struct vertex shader input. Let's see, float 4, start, pos, position 0, float, in pos, position 1, float 4, color, color. That's what our semantics are named. Let's do input, vertex shader input, vertex shader output, and let's do a float for. Oh, hi there. How you doing? Maybe we actually want a geometry shader. Yeah, I think so. We want a geometry shader. I'm pretty good. Just doing a short stream here before I have to go. Working on some debug stuff. Let's see. What are you up to? Oh, I'm happy to hear, man. What have you been working on so far? But I'm not happy to hear that you're sick, of course. Sucks, man. Alright, so if we add 5 to this. Alright. That sounds pretty good. Uh, let's see. Vertex shader. And then a float for color. Let's see, in, out, line, stream. Mm. Uh, yeah. What will your engine be able to do then? Yeah, what would you be able to do then with your engine? Uh, oh yeah, of course I need to update this, right? Don't I? Maybe not. Oh, it's that advanced, or that seems pretty intense, man. You already have running physics? Let's see, is it because I need to do this? Yeah. Let me show you in just a bit when I'm done with this shader. Start, yeah. Um, of course we need the pass data. Oh, sorry about the whistling. When you got that good music going, it's hard not to whistle. When you're an old man like me. You know the feeling? Yeah. I'm happy to hear that I'm not alone, enjoying myself. Okay, past data, yeah. Wanna be one of them. Yeah. Oh, goddamn, that sucks, man. That sucks. Let's see, does this actually compile? Not exactly. Okay. Okay. Um, well, not more in depth yet, but I will. Uh, yeah. I guess it's something that could get like more explicit down the road. Oh, let me see these input element here. Semantic index. Oh, that's why. Yeah, okay. So I need to actually let's do semantic index as the last element here. Even though it's awkward, it should still run. Right. And then this does compile, right? I think so. Uh, yeah, exactly. So I even saw scientific papers arguing that it would be an potential alternative to actually oxidizing by heating or burning or whatever. Yeah, so I think I'll create some kind of like electrolysis plant. Uh, okay, let's see. So we pass this in and build input layout here. Let's do input details. Whoops. Dot semantic index here. So this should work, right? No, not yet. Oh. Does not match the input. Oh, of course. It's actually specified as a line. Yeah, obviously you could do some kind of like thing where if you get more oxygen, you could actually start burning stuff. Yeah. But yeah, as far as I know, the process needs some heat at least. So yeah, to terraform a planet, as far as I know, you also need to release some CO2 to the atmosphere. So, uh, um, so let's see. Okay, this is not great. So let me just fix this D3D primitive point actually, and then swap this back to point. At least for the input. Okay. Um, I think he should be someone who had crash landed on a planet. That's the typical thing. He can't get home, but Dr. Mann in Interstellar is kind of stuck also. He also crash landed, but he had to like send a signal back for someone to provide the resources to actually build a civilization on the planet. This dude here should be using the local resources to actually terraform the planet with whatever stuff he has left from his kind of like spaceship. Yeah, exactly. Yeah, you could do that. Also, he should be able to find like canisters of whatever stuff he needs. Maybe some hydrogen chloride or uh, stuff like that. Maybe even some futuristic tech that does some stuff that is needed to explain why he can. Yeah, I've played it. I've really enjoyed it. It was a great game. I really loved it. Okay, so we have this. So whenever we create the pipeline itself, let's see. Yeah, I don't think I want the maybe I can even just do this. Let's see. Or there's a tour, Subnautica tour on the way. Let me see. But yeah, huge enjoyer. So this is a series of points, but it accepts the line topology. So let's do point here. But why doesn't it accept that one? Did I specify it somewhere? Hmm. Yes, there's a Discord link in the description down below. I probably won't have time to answer you today, but I'll look into it tomorrow, depending on what you're asking, of course. Okay, so I mean, this pipeline up here is line based, but it of course doesn't use a uh, um, what do you call it? It doesn't use the same pipeline stuff. Where did my Skybox pipeline? Debug sphere. Yeah, it went. Well, I guess you can change topology while you go. Okay, let's try point here. And then simply accept this. Okay. Okay. And let's try doing some draw calls then. Let's see. So in our application, we want to test our line calls here. Cast race, cast debug race. Let's do call grenderer. Oh, I haven't implemented yet, I guess. Oh, I do have implemented it. Let's do core. Oh, did I debug radar? Am I allowed to? Oh, whatever. Core debug radar. Ray. That's great, man. It sounded like a somewhat horrible situation with a bad USB. Let's see, endpoint here. Let's do then 1, and then do ray in color. Let's create a green, rather red one when then. Whoops. Okay, we do the call. We register the ray. We do the draw call here. We do the clear here. I mean, ah, that makes sense. Okay, let's see if we run without a memory leak. Yeah, no memory leak. Fine. Let's see. Then let's do our draw call. Let's do some stuff like this, although we're obviously going to disable all of this. We don't need this one. Oh yeah, the topology itself. Let's see. Okay. Let's try that. Oh, whoops. I'm changing the wrong section here. Okay. Let's see if this runs so far. So far, no problems. Then let's do CMD list. Draw instance. Vertex count 2. Now 1. Instance count 1. Start vertex location 0. Start instance location 0. Okay, so far we don't render anything. Oh, we have a error spamming down here. The primitive. Okay. So I should change it. D3D primitive point list, I guess. Primitive point list. Let's see. Okay, our line is ready. So we actually. Let me show you in a sec. Maybe, I don't know if you saw it. Let me just debug this last. Oh, that's because I create the vertex buffer in a wrong way. Debug array data. There we go. So the stride was wrong. Okay, so we actually draw lines like this. And it should be from our endpoints. Oh, something's wrong here. Something is definitely wrong. Let me just debug. Oh, I need to update the shaders, I think, because I changed the folder structure. There we go. Okay, so let's see, resource, debug, array, line vertex buffer here, float 4, float 4, float 4. Oh, it does get uploaded correctly. Hmm. But it's not pointing in the right direction. So that's pretty weird. And let's see. This is the ImGUI stuff. Draw instanced. Mesh viewer. Vertex shader output. Yeah, it does. Vertex shader output. Position 1. Oh, it flips it somehow, right? Uh, Yeah, this is not correct. Because the x is -1, the y is 2, and the z is 0. But this gets offset somehow. Yeah. Yeah, so the vertex shader is the problem. At least so it seems. Huh? That's pretty weird. That's pretty weird. Isn't it? I mean, what's going on? What's going on? Did I mean, I think I just saw that the vertices weren't correct. Or rather, yeah, the input to, I mean, this was right. I mean, -1 on the x and +1 on the x, and the y is the same, and the z is the same. So, Bloom pass buffer, okay, down here. Draw instanced. Huh? Oh, now I know. Now I know. Now I know. It's because this doesn't match the input signature, of course. Sorry about the shouting. Sorry about the shouting. Can't help myself. So let's add an alpha here, and increase this to 16, and there we go. Now we should be right. Yeah, so our line is perfectly horizontal. Let's try adding another one. Let's create a green one. And let's do it on the z-axis instead. So let's make a small X or cross or whatever. And inside our renderer here, in our loop, we will do count here instead. Okay, our second line doesn't get drawn. Okay, let's try debugging that draw call. Maybe it doesn't know that it should draw instance. Oh, it only counts one. So that's problematic. Let's just add one last one. And let's do debug raise. Let's do a gxe print here. Count, concept. Count 3, so it should work. Okay, let's see in render doc. What do we end up with? Oh, we do draw 3 lines now. Okay. The color is obviously not correct because the pixel shader is not set. So what happened? Did I just not build the right version, or I don't know. Didn't I add it? I don't know. I really don't know. But it works, so let's just update our pixel shader. Okay. Pixel shader here. Geometry shader. Input. Input.color. There we go. And we have our actually axis drawn here. Okay. So are you still here, Echo? Yeah, so did you see that I created some iron extractors that that are able to collect resources and accumulate resources inside them? Ah, okay. I've added a big one that spans several fields here, and we have support for different resources. So yeah. Next, I'm gonna do some iron processing, the electrolysis thingy, I think, and maybe some conveyor belts. Probably the conveyor belts, but yeah. Um, Other than that, I've just been doing some fixes here and there. Debug pass, primitive pass, debug ray pass. Yeah, sadly, I do not have much more time for today. And also, I'll be doing something very interesting in a not so distant future. I want to do indirect execute and GPU frustum calling. So not on the CPU side, but on the GPU instead. And this will speed up our CPU side of things, maybe even with a C pre-pass as well to save the pixel shader. And then when we have that performance, um, coupled with instance rendering wherever we need it, um, um, if I do more render work, I'll probably add some PBR to get a better visual style. Um, but I'll interleave it with like gameplay programming. So whenever I get like stuck on a mechanic or a bug, or not necessarily a bug, but a you know, more game mechanic style problem, I'll just pause it and then do some rendering work. Okay, did our toggle actually work with our rays here? Yeah, we can hide them. Okay, great stuff. Anyway, I really don't have any more time today, so I gotta go. But thanks for tuning in and hanging out with me. It was, as always, very nice. Hopefully, I'll see some of you guys here again on the channel. And Echo, you of course know where to find me. Feel free to spam screenshots of your engine work in the Discord server. It's always nice to see people's projects coming to life. And get well soon, right? Bye bye. Take care.